Welcome back to Startup Chuck. Today I'm going to go over the process of stripping down old battery packs with 18650 cells, testing them and rebuilding them into a sweet new big battery pack for my electric go-kart. Also, I rebuilt the battery pack for my electric skateboard while I was at it, and we tested it out in the parking lot and had an awesome time.
Here's the battery that failed. And if you look closely, you can see it got hot. Basically, super duper hot, causing it to bulge out. I mean, these things must have just been smoking. I think, however, though, this is due to overcharging and not during running in the go-kart, but who knows? All I know is that they failed, so these will need to get replaced. While we're here, let's check out this amazing four-wheel drive go-kart that we built here. So I built this thing with my daughter Carrie, like 4 years ago. It's pretty sweet. It's got four skateboard hub motors here. And basically, we just took the shaft on, this was a Razor go-kart frame. And so we just took the where the bearings were and basically just welded the axle straight onto it. And then added some weld and put some rectangle sections on there as well. Same thing down here. Just added some weld and filed it till it was a square shape to fit into the motor there. And then the rest of it, we got all four motors running off of these four Flip Sky VESC speed controllers, all hooked together, talking through CAN bus. They're pretty cool because you can actually talk to them via the app and hook up to them with Bluetooth, and it will transfer all the settings from your app to each of the four at once, which is pretty nice. And there's a gas pedal and a brake pedal. Those are just Hall effect pedal sensors I got online. Pretty straightforward with some 3D printed blocks to hold them in place. And so this awesome pink death card is pretty fun. The problem I had when I had just the lead acid batteries on there was the gas pedal would work fine, but if you hit the brake pedal too much, the lead acid batteries couldn't take the incoming charge, and so it would then overcurrent and cut out the electronic braking. And so you'd go from having some brake to no brake, and you'd have to back off and then feather the brake a tiny bit just to get a little bit of brake. And it was always terrifying because you might be going 35 miles an hour and then you hit the brake too hard and it cuts out and you have no brake at all, and you just got to steer for dear life. Either way though, so new batteries should make an improvement on that. So we're going to switch over to some lithium ion batteries, which is what I've got over here. This was a lithium ion pack that my buddy Rich had in his electric scooter, and multiple sets of the cells had failed. And so I had cut them out and basically just jumper soldered wires to make it a still working viable pack. So instead of it being 48 volt, it went down to 36 or something like that. Either way, I'm going to redo this balance connector because I think the reason that the pack keeps failing is I think this guy's bad. I'm going to work on separating out all of these modules so that I can then rebuild this entire thing from scratch, fresh. And so we are just going to start separating and clipping all of this. Stop charging this for now. Okay. All right, clip off these grounds. Whenever you're separating stuff from a battery, word of advice, clip wires one at a time. You never want to accidentally clip two and then have a short. Wouldn't that be bad? All right, Let's see what we got. Trash. Oh, maybe actually I'll keep those. This looks like some sort of almost like a polyimide tape, which is usually orange, so I'm not used to seeing green. So we're just going to rebuild this entire battery pack. Let's chop all of these. Yeah, just like this. This is the one now where I need to check all the different bad voltages again. See which ones are actually bad. Gonna make sure I never fold this thing back up without those dividers. I also have a nice spark, 3.6. This guy's the dead one, 0.17. So nonetheless, one of these is completely shorted the whole bank out. So that whole row is bad. So we're just gonna mark this guy bad. We're gonna eject him out of there. It's probably got at least one bad cell. I think those cells are bad too. So we're just gonna say bad on those. So if that's positive, I can put that there. I can go over here. Try and charge up this guy. This guy's charging slowly, so I'll let him go. I mean, basically, if the bank doesn't seem to be sucking any current in, then it's no good. What is this white stuff? Is that corrosion? What am I looking at? Don't know. Weird. It's interesting because as you're going through and looking at cells, you find ones that have corrosion, and you can tell they're basically leaking out. It's not even corrosion, it's just leaking electrolyte, but that was one of the bad banks, and you can see what caused it all. So it'll be interesting to see what these batteries test at, if they become, if they test okay, or whether or not that just killed the whole line. We're going to find out. All right, well, I decided just to separate every single cell so I could actually just build these packs right. And so that's what I'm doing. Separating each cell, then we'll test each one. And just be super careful when you're working with pliers and battery cells that are charged up. You want to make sure that you are not accidentally creating a circuit. Should be really bad, right? So I'm putting all of these stored face up, and then I'll go through and I will test capacity on every single one. And if I end up getting little bits left behind, I use this nice super sharp, I don't know if those are needle nose snips or what you want to call them, but they really help. So either way, pulling off all these old tin strips, and then I'll put new ones on soon after. Behold, I got them all separated, and I only cut my hand just a little bit on my palm, and no arc flashes during all of it. Can't believe it. So now the long process of charging and discharging up these, determining capacity and internal resistance, and then matching them into banks of 6 so they all have a summed capacity in each bank of 6 that matches each other, and hopefully similar internal resistance, and we'll go from there. All right, so I just finished testing all these battery packs. These are all my good batteries. They're all charged up. And these are all my bad ones that weren't going to work anymore. I just can't charge them. They don't show any voltage. They're essentially 100% dead. Give me a thumbs up, bud. All right, so I'm trying out this sweet new battery welder I got. It's kind of cool. Acts as a battery backup, power bank, and just basically has a big battery on the inside and dumps a ton of current in all at once. So you can set pulses and duration and preheats and how many dots. So dots is like 3 pulses in a row, things like that. And it's just kind of automatic. So you put on your welding tab, right, like that. And then I'm going to basically just lightly hold it down. And that's it. Welded it super nice. Okay, that's it for that bank. Turned out pretty sweet. And I got these little tabs that I'm going to solder to.
All right. So you know how when you're working on a project, you see another project and then you think, well, maybe I should work on that too. So now I'm in a project within a project, which is not that far off from what I was trying to do. So I have this electric skateboard. Here's this electric skateboard. It was basically bolted in like this. It started not charging. So if you're ever wondering how most electric skateboards, you can get that panel off, you basically lift up the sheet, or if you're like me, put a little hole wherever the screws are. You can usually find them with a magnet. And then you unscrew all the connections. And then I popped out the battery. And the battery looks like this. It was essentially this 25.2 volt, which works out to be 7 cells in series, and 4,000 milliamp hour, 4 amp hour. So either way, the inside of it looked like this. I completely rebuilt this guy too, and combined it with some of these higher capacity. Well, actually, these are 2600 and these are 2000 milliamp hour. So a little bit higher capacity now, but the big thing is these have a higher C rate. Before these guys were, I think, 2C. Now they're 5C on these purple ones, so that'll help out a lot with current draw. And I had probably 6 bad cells in this whole group. as evidenced by the fact that I replaced half of them. So between this guy getting completely rebuilt and this battery pack getting completely rebuilt, I have now doubled up on the projects I'm working on. But that's okay, because at least all my things that had battery packs that weren't working will now be working. Another thing, I want to give a shout out to this SWM10 or Swim 10 battery welder. Probably done 1,000 welds with this. Right now when I weld it, the current kicks up to between 450 to 650 amps of current going through these 8-gauge cables, and you can feel them separating due to the electromagnetic fields they create, and they heat up pretty hot after about, I'd say, 25 spots in a row. Well, 25 times 3, so really 50 to 75 welds in a row, it basically starts to get pretty hot. But by that time, the battery voltage has dropped down to about 3.7 volts, and it'll under voltage and tell you to go charge it. Also, the temperature of the system itself will usually start creeping up above 40 degrees. So it's better to go charge it anyways, let it cool down, and then you can go back to welding. So welding turned out pretty good. I don't know whether or not this will just pop off the wide angle. Is that going to show the tabs well enough? Kinda. I mean, I put 3 double tack welds on every single cell, and I think this will work out. So the next step is going to be attaching the battery management system, which, if you look at, let's say, this old battery pack, it's got a resistive battery management system, which, what does that mean? Well, it means you've got all these little resistors on the backside, which isn't very efficient, versus I got another version here. This is an active battery management system, and it's a lot more efficient. So what it does is basically it will take the different cell voltages, and if any of them is lower, it will shuttle power through capacitors from one side to the other. So it basically just has a ton of MOSFETs on the backside instead of resistors, and it will constantly shuttle power from high cells to low cells, and that is way more efficient because you're not just burning energy due to resistive heat. If you want to get fancier, the next thing I'm going to be using for the big battery pack is this guy. And this guy will actually do 18 cells, I think. 17. 8 to 17 cells. So charge at 60 amp, discharge at 60 amp, balance current is 1 amp. It is active balancing, so it will shuttle things around in its capacitors. It's got built-in Bluetooth. It's got built-in temperature monitoring with these NTC probes, which stands for negative temperature coefficient, if you've ever wondered. And you can even download an app on that little QR code and then connect to it via Bluetooth. So I'll be hooking up the battery pack with this guy and have a little bit better control and hopefully not blow up this pack that I've spent 10 hours now rebuilding. All right, we just got this battery pack installed, and now we're going to test out
These wheels. Some of them need a little bit of a spin. All right. Seems like it's working. Pretty awesome. Now let's see if the app works. Showing me I got 99.8%. And it gives me all my individual voltages for each different bank. All right, we got this thing back in. So let's remount it. Oh yeah, full battery. How's it work, dude? Let's see it. Yeah, hop on. That's fine. All right, let's get this battery pack mounted to our sweet super kart.
Where am I going? Just driving around? Whee! Circle! Whee! Circle!
Brakes work! Whoa, I've never had working brakes before. I seem to be stuck. I heard a loud pop. I wonder what the loud pop was. All right, so we were testing out the new go-kart, and I heard a loud pop, and then all of a sudden it stopped working. So, seems like the new battery is working great. The short circuit protection on it, though, is flagging. And so now I'm having an issue where the wheels are spinning okay, but this one over here has a lot of resistance. Almost feels like it's trying to break, which tells me that maybe we fried the MOSFETs in here and it fried them in a shorted configuration. Yeah, you should not be getting continuity so easily. So something is awry. So let's chop the power cable on this speed controller and see if it fixes the problem. I'm just going to cut one, and I can crimp it if I need to. Let's see if I no longer get... Oh! No, I don't have a short. Nice. All right, so I just chopped the power lead to this speed controller, and now I don't get a short circuit anymore, which means this speed controller is no good. So let's chop it. It's cogging really weird, so I can feel the motor having a lot of resistance, even though two of the lines are disconnected, which tells you that maybe there's a short up in here, or maybe down at the motor, and maybe that's what burned it out. Yeah, I still feel it cogging really weird, so maybe the motor died. Since I'm getting some weird cogging in this wheel, let's open it up. Everything here looks fine, which tells me it's probably way down there at the joint on the inside. So we're gonna have to unbolt it, check it out. Let's play the guess which wrench game. All right, so I pulled off this motor And I bet you that a couple of these windings are going to have really weird so 0.4 ohm on one leg, 0.5 ohm on another leg, 0.5 ohm on another leg. There we go. A nice motor core. Cool. All right. Okay. So I just pulled the motor apart. Wheel pops off easy with some screws. And then core of this guy seems good. None of the magnets are loose, so I don't think any of those are hitting. Seems to spin nicely, so I don't think it was a bearing. Same on this end. But if I start looking at this guy, the wires seem to be getting pretty worn. So all the Hall effect sensor wires have just been completely destroyed. And let's try and see if we can see what's going on here. Oh yeah, look how good these are. Completely delaminated. So these guys all shorted. And same thing with this, completely shorted. I don't know if you can see that easy enough. But yeah, essentially this is the problem that I was having. I think the reality is these electric skateboard wheels are just not designed for the load and the current I was putting on them. Oh, it looks like there was a zip tie also. Sorry. Also, it looks like there was a zip tie that was holding things in place that slipped or broke or something. So, either way, yeah. Internal shorts, ruined my speed controller. Bummer. I just saw how the motor destroyed this speed controller. And that's a big shame because, well, I really liked it, but it still has a short internally. So let's take it apart. I've actually designed bigger versions of these before, so I know pretty well how it works. And if you've never looked up field-oriented controlled or FOC controlled speed controllers before, they're kind of neat. Essentially, you can measure current using these two current shunts on any two legs, and you can then calculate the amount of power going between all three legs of your motor, and then using some really fast math you can control the motor to spin smoothly without having sensors, Hall effect sensors. And so they use that on a lot of EVs. So for example, my electric motorcycle had a FOC controller. I actually built my own electric motorcycle. You can see it on evalbum.com under Electric Love. It was a cool Ninja 250. Loved it. My guess is, since we had a short, we have blown one of the large MOSFETs on the backside. And so we'll see that right here. So, yep, I see the magic smoke. So, if we're to zoom in on this, we're going to see a couple of bad chips on here. See how close I can get. Right about there. And so pretty clear to see. Right here, you got a nice streak of smoke. Over here, you got some charring. And so you could possibly, I don't know what other damage there is, replace these guys. And it might fix it, but that's a lot of work potentially. May or may not end up working after that. But if we're just going to look at this entire thing in the meantime. So here's your microcontroller that controls everything on the board. It does all the I/O. You've got a driving chip. At least I think this is a driving chip. And it then handles all of the smarts for controlling the motors on the backside with these guys. Big diode to prevent basically backflow. And then some capacitors to even everything out. And kind of that's about it. Lucky for me, I just need to find another one in my big box of speed controllers. Well, would you look at that? Also, I need a new motor, so I'll just go to my big box of motors. See what I can find. Not that one. Here we go. That looks similar. One of these will work. We'll find out. Oh. This is looking promising. Yes. All right. I just got this guy all cleaned up. So now we're just going to have to program things. Load default parameters, sure. All right, E-skate, 750 gram. Yep. Lithium ion, 15.6 amp hour. That's how big my battery is. Next. These are 90 millimeter wheels. They're direct drive. Okay, it's going to detect all of them over CAN bus. So all four of these guys are hooked up on CAN bus. And it's going to move the wheels on each one independently. Look at them go. Woo! All right. So, and then does some fine motion checking left and right, which is pretty sweet, etc. So here's all the info. Cool. Sweet. There they all are. So let's check directions. So I'll hit forward, and it looks like it's going backwards. So I'm actually going to invert all of these because I think they're all wrong. I'll check it. No, actually that guy was right. Try again. Okay. All right. Sweet. Okay. So forward is correct on all of them. Finish. Set up input. ADC inputs. Let's see. Here is the gas pedal. You can see it is moving perfectly. Okay. Same with the brake. All right. Applying right. Yep. Now I get a full range each time I use them. Next. And then control type. We want to do current reverse with the second analog input as the brake. Brake button. No current, no reverse. Brake, ADC. There we go. All right. Regular safe start. Right configuration. Next. Whew. All right, that's definitely working. Here we go. Battery current max. I'm going to change this down to... So this is per controller. So I want it to do 15 amps and another minus 15 for regen. Okay.
All right, we're ready to do our second test drive. I want to ask you to please make sure you subscribe. I want to try and hit 1,000 subs by the end of the year, and your subscription will really help me out with that. Plus, I'm going to have some really cool videos soon where I'll be smushing things in a centrifuge, and it'll be really fun. So make sure you subscribe, and now let's check out the test drive.
We just fixed this guy up again, and we're going to give him a shot. Ready, Max?
Okay,
Let's see the speed. Yeah. Woo! All right, do some donuts.
I don't know what'll happen.
Oh, geez, he did a 2,000 watt burnout.
What?
He's going fast.
It's really fast. It's kind of scary.
I'm just glad the brakes finally work again.
Yeah, it's okay. I'm glad it works in general. Don't hit me. It does go pretty fast.
All right, give Carrie a shot. All right, how is the speed demon?
Good. It's just don't slide off. The seat needs a buckle.
Yeah.
It doesn't. Especially in the rain. The seat needs a buckle. No, it doesn't. Yes, it does. Not this. You can't go fast on turns.
No?
I'm not going.
All right.
You need a seatbelt.
Pulling real-time data here while the thing's running. We'll see how it's doing. All right, back up, Max.
You got this, Gary? I guess. Are you gonna go gas all the way during the straight shot? Gas all the way.
Off she's going.
Brake. This thing's so fun. Oh my god. That's really fast. I'm scared.
Oh, yeah?
Yeah. You gonna go through that loop? Come on.
All right, let's check out some data. See how fast it can go.
Okay, no, give it to me if you're scared.
It does need a seatbelt. It does need a seatbelt.
Yeah.
We're right.
Give me it. Give me it. Give me it.
Done.
Woo! Oh my gosh, this thing's too fast! Oh my gosh. Oh my gosh. This thing's a little terrifying. Woo! Oh no, the brakes cut out! Ah, feet down. Oh, they work. Brakes work if you go lightly. You got to keep the braking current to less than 60. Oh, this is cool, but it's raining a lot. Time to go. Whoa! Better answer this. Hello, I'm on the go-kart and it's pouring rain and I'm getting it in the car as fast as I can. Bye. I know it's pouring rain, so yeah, it'll break it. I'd rather let's not break it.
Okay, let's do it when it's sunny again.
Because if we just get some rain accidentally on these connectors wrong, this whole thing's gonna fry. All right, quick! It's pouring rain.
Yep.
What kind of pit crew is this?
We're not a pit crew, we're your children.
How quick can you change the tires?
Not at all, we don't have tires.
All right.
Do it for you.
Maybe not leave the battery next to the sharp wheel.
Ooh.
Amazing.
That thing's awesome.
All right, wow, this thing was fast. That new battery is significantly lighter than the old one. First one was about 22.5 pounds, the lead acid one. Now I'm about 8.5 pounds. This thing is able to put out so much more current. It's able to soak in so much more current during regen. So the brakes actually work now. I think I easily hit 30 miles an hour based on GPS, but then if I had a long enough parking lot, probably could hit 35, maybe 40. I don't know. The rating of the motor and the voltage of your battery pack will determine your absolute max speed. And I can't remember what the kV rating of the motors were, so it's kind of hard for me to figure out the max speed. But either way, it is way more fun. Definitely needs a seatbelt, so I'll be getting a seatbelt on that thing, so that way you can really start trying to push it around corners. And overall, big success. I'm happy, kids happy. Please check out my other videos and like and subscribe, and I'll see you guys next time. Thanks.